Hey everybody, Zach Howell here, Biomechanics of Sport. We're going to be talking about coefficient of friction today. So for that purpose, I actually these shoes that have some spiky bottoms, so they're rubber soles that have spiky bottoms on it, which is actually what's going to increase the coefficient of friction here between my shoes and the asphalt. It's going to give a greater grip, okay? So that way whenever I put force into the ground, it's going to cause me to create more friction, which is going to help propel me forward. So the way this works though is if I say, depending on how much area and how much force, regular contact force I'm putting into the ground, right? If I put a ton of force into the ground, but I'm only up on my toe and pushing straight off of my toe and running on my tiptoes, that's going to limit the amount of friction that I can produce and propel myself forward. Same thing goes if I put the same amount of force into the ground from my toe as if I strike my midfoot, even though the surface area increased, because because the amount of force stayed the same, therefore the amount of pressure as I push off of my foot actually decreases. So it doesn't actually help me. What's going to help me whenever I run and increase my propelling speed is whenever the coefficient of friction between my shoe and the asphalt interact with a great amount of pressure over a great amount of surface area. So when I start running, when I'm up on my toes, like this, that doesn't help me create enough force to propel myself forward. So what we want to do is we want to increase the amount of friction by increasing the surface area and the amount of force into the ground. And as that goes, the coefficient of friction increases. The amount of friction that you produce increases with the amount of force you produce. And that is all about the coefficient of friction.